Hello geometry students, and welcome to a video that's part 2 of angle addition and angle bisector. This is lesson 3-2. Part 1 covered everything about angle addition postulate, and then again we just use the word postulate. That means it's something that's an assumption. It doesn't need to be proven. And now we're going to talk about the angle bisector, and that's sometimes called the angle bisector theorem, but we're just going to call it angle bisector rule. Okay, so what I want you to do is I want you to take your paper. So we've already gone through examples 3 and 4. I gave you the answers, and I did example 5. So there's one that you have to do there. I did 6. You're going to have to do 7. I did 8. You're going to have to do 9. And we're going to talk about 10 right now. We will do 10 together in a minute. But first, if you could turn your paper over so you get a blank paper. So I can just kind of make sure that we're clear about what the angle bisector actually means. Okay, so there are two things in angle bisectors that I'm going to refer to that we've already talked about. And the first one is we've already defined it on our notes for lesson 3-1. That was on Monday. And we defined it right here. We talked about an angle bisector. That if you have an angle and you have a line that goes right through the middle, creates two equal angles, that's an angle bisector. And that line is usually a ray. It doesn't have to be a ray. It can be any line that goes through it, cuts it into half, so that there's two equal parts. Okay. The other thing I want to remind you of is that this is everything in segments has a counterpart with angles, and this is very similar to the midpoint of a segment. And in the definition of the midpoint, and this was notes from last week, 2-3a. This is notes 2-3a. So last Friday of week 2. We talked about what a midpoint is. It forms two congruent segments, and we related that to a segment bisector. So we're doing the same thing to angles that we did to segments. And that's why the word bisector is the same word. We're cutting angles in half with a bisector. Something that cuts an angle in half is a ray. We cut a segment in half, like this segment AC, with something that cuts segments, like it could be a line, or it could be a ray, or it could be a point even, anything that cuts it in half. Okay, so we're going to just kind of write down the rule here on the back. So the angle bisector, and I just want you to get used to drawing a little bit, because sometimes when all the notes are printed out, you lose something in that. So let's draw an obtuse angle. Okay, let's label the angle ABC. A, B. B has to be the vertex if we're going to label it ABC. And then this would be C. We can put arrows here. It's really not necessary every time. Now let's do our best to just sort of eyeball an angle. When I say eyeball it, I mean you don't need to get a ruler out or get a protractor and measure it. You can if you want to. But we're just going to try to eyeball what would be an angle that goes right in the middle that make two equal angles. And so I'm going to do my best there. Now, sometimes you're going to be off, but you try your best. But the way we're going to show that this makes an equal angles is we're going to mark them equal. And those marks actually override what's actually there. So that's why we see the term not drawn to scale. And you'll see this every once in a while in your textbook, on handouts, worksheets. You'll see it for sure on like tests like the SAT says it all the time. They want to let you know that you can't rely on what it looks like. You have to rely on the marks. Okay, that's what's really important, or the numbers. Because if I had a 50 for each of these, they would also be equal, and this would also be an angle bisector. I'm going to give the angle bisector a point, and I'm going to call that D so that I can write down a rule. And I'm actually going to give each of these angles 1 and 2. So I didn't really need the D, but I'm giving more information than we need here. But yeah, I do need the D, because we're going to say if, we're going to write this as an if-then statement. Okay, so if ray BD is an angle bisector. So we're going to not write the word ray. We don't need the word ray. We have notation. So BD with that ray symbol over it. So if ray BD is an angle bisector, and if always goes with then. If it's an angle bisector, then the measure of angle 1 equals the measure of angle 2. Okay? And by the way, this works in both directions as long as they're connected and it's part of the same diagram. All right, that's the rule. Now we're going to look at an example with numbers, and then we'll look at an example with variables. All right, so example 1. And the example with variables is actually the other side. That's the one that we're going to work on together. So example 1, let's say that we have an angle. So let's draw another angle. Again, you don't need, make this one a cube. Don't make it quite as big as the last one. All right, let's call this angle ABC again. Sorry I'm not so creative today. Sometimes we use things like dog and cat, but today it's just ABC. Oops, it's a C. Draw what looks like the ray that goes right halfway between there. Again, you're getting some practice drawing that and trying to get it accurate, trying to make it neat even without a ruler. And we're going to say that BD is an angle bisector. So we're going to say that it's given fact here. Given facts, one is that BD is an angle bisector. Okay, and then the other given fact will be that the measure of angle ABD is equal to 42 degrees. Okay? Not drawn to scale, because we didn't measure this to draw. We just drew it, and we didn't probably draw a 42 degree angle there. Mine's smaller, but again, not drawn to scale. Excuse me. Now we're going to find two things. We're going to find the measure of angle ABC, and we're going to find the measure of angle DBC. Now think about how we're going to do this. Now what we're going to do is we're going to label these are equal because we have an angle bisector, and the measure of angle ABD, that's 42 degrees. Okay, well we just said that they're equal. So without even looking at the question, without even thinking about the stuff that we're looking for, let's just think about what we know about this diagram. And that's going to sort of be a common thing to do in geometry. Don't always look at the question. We've already seen that. And sometimes, you're not asked about x, but you need to find x first, because that's what you can do. So in this case, what can we do? Well, we can say if these are equal, and this is 42, then this is 42. That's the meaning of the fact that it's a bisector. And we can also say by the angle addition postulate that these two must add up to 42 plus 42, or 84. Now let's see if we can answer the questions. Did we find the measure of angle ABC? Well, ABC is the whole thing, and yeah, we found that it's 84. Did we find DBC? Yeah, DBC, that's 42. Okay, let's turn the paper over and let's do the example on the other side that has some variables. Okay, so we're looking at example 10, and we're given this diagram to the left, and we're given some information. First information is that ray BD, it bisects angle CBE. So this is an angle bisector to this angle. So let's find CBE. So here's C, there's B, and there's E. BD is the one right inside there. So since this one here is the bisector, these two here are the equal angles. Okay, so far so good? Let's see what it says next. BC is perpendicular to BA. BC is a segment, BC is this one, and BA is this one, and this makes a right angle. How is that going to help us? I'm not even sure yet. Measure of angle CBD, measure of angle CBD. Okay, good. We can label that just like what we see there, 3x plus 25. 3x plus 25 inside there. We'll zoom in a second after we get the whole thing in. Angle DBE, oh good, that's the other one that's equal. So that's 7x minus 19. So this is what we have. Let's look at this for a second and think about it. We knew that BD was an angle bisector. So we said that these two have to be equal. Then we were given expressions for each one. Now what doesn't matter? The right angle. Not going to help us at all to find x. It might help us to find the final answer, but it's not going to help us find x. Okay, but what can we do right now? We know that we can find x. We're going to need it. Okay, we're going to need it for the final answer. So let's go on here and let's see how to use the angle bisector rule to find x. So we know that they're equal, so we just write them as equal. So 3x plus 25 is equal to 7x minus 19. Okay, now sometimes you're going to subtract, so be careful. It's not always addition. It's just like everything else here with angle addition. So what do we have here? We have, let's take a moment. You guys do your algebra thing, and then we'll compare answers. How about that? Okay, so can we agree, hopefully, that x equals 11? But we're not asked for x. This is just a problem that you're going to have to go beyond getting x. So we were looking for ABD. So let's go back to the diagram, and we need ABD. So let me highlight it. So we're looking for the angle that starts at A, goes to B, and goes all the way to D. So we're looking for that angle. And we're going to have to use the angle addition postulate here because we know that this is 90. We were given that. And we now can figure out what this is. So this, knowing that x is 11, we can just plug it in there. So we have 3 times 11 plus 25. That's 33 plus 25. That's 58. So this is 58. Now we're ready to find, using the angle addition postulate, I almost said segment addition, we're ready to find the measure of angle ABD. So let's just make a note over here that the measure of angle ABD is the sum of these two, and then we'll just plug in the numbers. So the measure of angle ABD is equal to the sum of ABC, the measure of angle ABC, plus the measure CBD, the measure of angle CBD. We know both of those. We know both of those, so we're just going to plug in the numbers. Okay, so ABC is 90. CBD is 58. Add them together, you get 148. So this equals 148 degrees. Well, that was a long problem, but there you have it. We're combining how to use the angle bisector rule with the angle addition rule, and they go together to give us 148. Okay, I hope you found this video helpful.